we have learned how to multiply two binomials together. We have learned how to square binomials. So one of the uses of using these things is to turn quadratics that are either the intercept form or the vertex form back into standard form. So this is just an application of stuff that you already know. So I'm going to do two examples of each. So if I start out with y equals 3 times x plus 2 times x minus 3, I want to turn this into standard form. So first thing I'm going to do is I'm going to multiply my two binomials together. Here's something I want you to realize. Multiplication is commutative, so order does not matter. But it is easier to do the binomial multiplication if these coefficients are smaller. So I can either distribute the 3 into either one of those, but not both, and then FOIL them out or multiply them out. Or I can multiply these out and then multiply my final answer by 3, which is going to be the easier method. And that's the way I'm going to do it. So what I have here is the first term. So first is x squared. Last is minus 6. Then the middle is 2x minus 3x is minus x. Then multiply that out, and I get y equals 3x squared minus 3x minus 18. Okay, if I was going from standard form back to intercept form, first thing would be to factor out the 3. Then I could factor this polynomial, two numbers that multiply to negative 6 that add a negative 1 would be the negative 3 and 2. Okay, so all I'm doing is I'm undoing the factoring process. Okay, y equals negative 1/2 2x plus 3 times 3x minus 2. Again, it's going to be easier for me to do the multiplication of the stuff in the parentheses, my two binomials, before I distribute that negative 1/2. So I'm going to leave the negative 1/2 out front. First terms are 6x squared. Last terms are minus 6. Middle terms are 9x minus 4x. 9 minus 4 is 5x. Multiply everything by negative 1/2, and I get y equals negative 3x squared minus 5/2 x plus 3. Remember, that negative sign goes into every part of our multiplication, so make sure that you don't lose it on the way in. So two basic examples converting it to standard form. You've already had problems that said, hey, multiply those things out, not realizing that you were already doing this type of work. Next one is converting something that is in intercept form into standard form. And now I've got to make sure I follow this order of operations. I need to square this first. I can't multiply by 3 and then square it. I have to square it first. So y equals 3 times something squared minus 5. And that's a memorized pattern. It's the first term squared, last term squared, and 2 times the product. 2 times negative 4 is negative 8, times x is negative 8x. Distribute the 3. Y equals 3x squared minus 24x plus 48 minus 5. Add the 5 to both sides. Add the 5, combine the 48 and negative 5. Y equals 3x squared minus 24x plus 43. And one thing I want to show you with this last one here, even with all of these. So here, I know I have an x-intercept at negative 2 and positive 3. When I multiply it all out, I also know my y-intercept. It's negative 18. Here, I know I have an x-intercept at negative 3/2 and positive 2/3. Multiply it out, I have a y-intercept of 3, and it's upside down. This one's right side up. Here, my vertex is at positive 4, negative 5. I have a y-intercept of 43. So that's one of the reasons why you may want to multiply it out, because it may be easier to find the y-intercept. Well, and a y-intercept is also found just by putting a 0 in for x. Put a 0 here. Negative 4 squared is 16. 16 times 3 is 48. 48 minus 5 is 43. Okay, multiple ways to come up with the same information. I'm going to do one more of those squared patterns. Y equals negative 2/3 times 2x minus 1/2 squared minus 5/3. Okay, again, I'm doing it with fractions just so you can see I use the exact same process. I need to follow my order of operations. Order of operations says to square this thing first. So first term squared would be 4x squared. Last term squared would be 1/4. 2 times the product. Negative 1/2 times 2x is negative 1x. Negative 1x times 2 is negative 2x. Oop, no squared here anymore. Distribute. Y equals negative 8/3 x squared plus 4/3 x minus 8/12 minus 5/3. Okay, these two terms I don't have to come up with a common denominator because they have different powers. But this one I do. I need to have 12ths. So what I'm going to do is multiply the numerator and denominator of the 5/3 times 4 and write my final answer. Y equals negative 8/3 x squared plus 4/3 x. Negative 8 minus 20 is negative 28/12. 4 goes into both of these. 4 goes into 28 7 times. 4 goes into 12 3 times. So I'm going to end up with negative 7/3. And that would be the final answer for this being in standard form. Now, let's look at what information I have here. I have my x-intercept is when this is 0. So that is 0 at 1/4. Okay? I mean, my vertex, x-coordinate of the vertex is at 1/4, comma, negative 5/3. My y-intercept is at negative 7/3. Okay, I purposely picked this one messy with fractions just to make sure that you realize even when it has fractions, I still must follow those order of operations. The only point where I needed the common denominator was with the constant terms, because these, I'm not going to combine these and write everything over 3. I guess I could pull the 1/3 out, but I want it in this form. Okay. Now, my first step in factoring would be to pull a 1/3 out of everything. But right here is our standard form, and that's what you need to be able to do. Convert either intercept form or vertex form back into standard form.